Now this is the second lesson in Chapter 10. This looks specifically at trig graphs to begin with and solving equations. So we need to know the properties of the sine graph, cosine graph and the tan graph. Now you can actually create this graph by drawing a table of values, which is actually what we did in the warm-up, plotting the points and then joining them up. And if you had sufficient points, you'd find this pattern. So a few characteristics: the highest point is 1, lowest point is -1. Starts at 0 and it has intercepts at 180 degrees and 360 degrees. Notice also all the values that are above the x-axis are positive values. So quadrant 1 and quadrant 2 are positive, which if you go back to CAST, quadrant 1 all things are positive and quadrant 2 sine is positive. So that actually backs up our work on CAST. Now we can also draw the graph of the reciprocal function as well. So if I was to draw the graph of cosecant, cosecant is 1 over sine. Now if I do 1 divided by 0, I actually get infinity. So it's undefined, so that means I'm going to get an asymptote. 1 divided by 1 is 1. Once again I got 0, 1 divided by 0 is going to be undefined, so I'm just going to put it up here next to an asymptote. -1, 1 divided by -1 is -1. And I'm going to have the same problem in a second. I'm going to be dividing by 0, which is going to give me undefined. Now, one thing people notice when drawing this graph before, previous students have noticed that if you take the curve and flip it upside down, and you get that, and do the same on this one as well, flip it upside down, so you actually get that shape, whoops, you actually get that shape there, which if I reveal, is actually what the graph of cosecant looks like. So the asymptotes are when you're dividing by 0, because that's not actually allowed. So there's your graph of sine and also cosecant. Here's your graph of cosine, just between 0 and 360. It repeats after 360 and it carries on in the same pattern. This time it starts at 1 and also finishes at 1. Highest value 1, lowest value -1, just like before. This time the intercepts are 90 degrees and 270 degrees. And we can do the same sort of thing actually with this graph if you want to find the graph of secant. So what we can do is we can take this curve, flip it upside down, and this part here, flip this one as well, so it's like this, and take this side and flip it. And hopefully that should look like the picture I have over here, which is my graph of secant. I've added in the asymptotes here, and the asymptotes occur when we're dividing by 0. So this would be 90 degrees and 270 degrees. These points here should be 1 and -1, because 1 divided by 1 is 1, and 1 divided by -1 would give me -1. Now our last graph is actually tan x. So I've gone from 0 to 270 here. So we actually do have asymptotes for this graph. So tan of 90 is actually undefined, and tan of 270 is undefined as well. And this graph actually repeats after 180 degrees rather than 360, which we saw in the previous question. Asymptotes at 90 and then every 180 degrees after that, because as I mentioned earlier, the graph repeats every 180 degrees rather than 360. Now we can look at the graph for cotangent, and it actually looks very similar. It's that same sort of flipping around. It sort of looks like it's going in the opposite direction, so instead of going like this, it goes like this. Asymptotes at 0, 180 and 360, because 0 is 0, 180 is 0 and 360 is 0, but we can't see that from the graph. So this would be your graph for cotangent of x. Now let's look at solving equations. Now when we solve equations we have to give a limit for what values we're actually looking for, or a domain. So for this question, and for all my questions, I'm going to go from 0 to 360. Oops. And I'm going to include 0 and I'm also going to include 360. There we go. So what I'm going to do is give you a visual representation of what we're actually doing first. So what we're trying to solve is, when does the graph of tan x intersect with the graph of y equals 0.3? So in other words, this. Now from this picture here, what you can see is that there's actually two intercepts here. Intersections. One slightly above 0 or one slightly above 180. So how do we go ahead about finding those answers? So there's our equation. We're trying to find the x value, so we want to solve for x. So instead of doing tan, we're going to do the opposite of tan, or tan to the -1. Then we're going to use our calculator. Now my question's in degrees, so make sure you're in degree mode. And to the nearest degree, we're going to find that it's 17 degrees. Now that's this answer that you can see here. Now from the property of tan repeats every 180 degrees. So once you found one answer, all you have to do is add on 180 and it will tell you the second answer. If these limits were bigger, keep adding on 180 and it will tell you all the rest of the answers as well. If we make tan negative, so tan x equals negative 0.5, what we're looking for is these intersections that you can see here. Now I'm not interested in this one because this one's outside 0 to 360, but I am interested in these two answers here. So first of all, we're going to do is algebra to find the first solution. Now the first solution is actually called the principal value, so that's something I should have mentioned for the previous one. Inverse tan, and we get an answer of negative 27, which looks good from the picture, just a little bit less than 0. Now we don't want that as part of our answer, but you need it to find the other answers. So as tan repeats every 180 degrees, add on 180 degrees. Add on another 180 degrees. If you add on another 180 degrees, you get 513, which is above our limit of 0 to 360. So this was our principal value, but it actually wasn't relevant for this question because it wasn't between 0 and 360. These two values were, so this is going to be our answer. And now we'll look at what happens with cosine. So let's look at cosine equals a positive value first, so 0.65. So I've just drawn in y equals 0.65 there, and you can see that there's two solutions to this question. So we find the first solution by doing inverse cosine, which gives us that principal value, 49 degrees. And then we have to find the other value. Now the thing about cosine is it's going to be symmetrical about 180 here. So if I know this distance here is 49 degrees, this distance here must also be 49 degrees. So this is 49 degrees less than 360, so I can work out what that answer is. Now for cosine, your two answers together add up to 360, and that's a rule that you should go ahead and learn. So what I actually did here is 360 take away 49 to give me 311. But your two answers should add up to 360. Now if we do one with cosine x equals something negative, then what we're looking at here is the intersections, and once again you can see there's two answers, one slightly above 90, one slightly less than 270. So set up the equation, inverse cosine, and your first answer comes out to be 109. To find your second answer, 360 take away 109 to give you 251, because together they must add up to 360. And that would match up with actually this picture here as well. So by symmetry it's 190 degrees from here, and therefore it's 109 degrees less than 360 as well. The other thing we can notice is with it being 109, this is actually 19 degrees past 90 degrees. Therefore this must be 19 degrees less than 270, which is also 251. So using the symmetry of the graph is important to find out those other values. And our last ratio is sine. So sine x equals 0.3, we draw in y equals 0.3, and then look at the answers, and we can see that there's two solutions for this one. Now there's not such a quite nice rule for this one, we have to use the symmetry of the graph to find the answers. But first of all, let's write the equation. Do inverse sine of both sides, so we can find x equals sine to the negative 1 of this. Calculator, 17 degrees to the nearest degree. And then we have to use the properties of the graph to find this other answer. So this distance here is 17 degrees, greater than 0. And this value here, by the symmetry, this must also be 17 degrees. But it's to the left of 180. So 180 minus 17 gives you 163. And that would be our two answers for this question. If we do sine x equals negative 0.2, draw in negative 0.2. Two solutions, one slightly greater than 180, one slightly less than 360. Set up our equation, do inverse sine, and to the nearest degree we get negative 12, which is not useful for our question because it's outside 0 to 360. What it actually is this answer here. So what we know is then that it's 12 degrees from here back to the x-axis. And we can use that to help us find the other values. So this must also be 12 degrees. As it's to the right of 180, that must mean it's 192. Similarly, 360, 12 degrees less than 360 would be 348. Now actually there's another way of finding this second value. If we notice the value as it's going up here, and it's the same for this one here, the property of sine is it repeats every 360 degrees. So if we take negative 12 and add 360 to it, that would also give us 348. So a couple of different ways of ending up with the same answer. That's your 6 basic questions. We've done one for sine, cosine and tan. One answer being positive, one answer being negative. So quick to review, tan, just add on 180 to every answer. Cosine, the 2 answers add up to 360. And for sine, you have to use the properties of the symmetry of the graph to find the answers. So we looked at how to solve basic equations. What happens if we get something slightly more complicated? Certainly there's no inverse cotangent button on our calculator, so we need to think of something slightly different. So what we can actually do for this is, we can actually do the reciprocal of both sides. So if we flip both sides, we get 1 over cotangent equals 1 over 5. And luckily there's a definition for 1 over cotangent. That's just the reciprocal of tan. So therefore what we actually have is tan x, or tan theta I guess in this case, equals 1 over 5. And that's a question that we know how to solve. If we have something more complicated like this, then we're just going to try and simplify it. We're going to try and solve for cosine theta. So first of all, let's add cosine theta to both sides. Let's add 1 to both sides. Divide both sides by 3. And then now it looks like something that you're more familiar with. Now this one's very special actually, because if we do inverse cosine of 2, it says error, which actually implies no solution. Think about why that's actually true for this question. So the graph of cosine goes like this, between 1 and negative 1. So we're saying at 2. And obviously there's not going to be any intersections at all, because this line is higher than the course of the graph. So this one will be no solution, but in general the principle is try and solve for the variable or the ratio, and then go ahead and solve as normal.